Hello everyone, I'm Mr. M, and today I'm going to be talking about difference of squares. So difference of squares is a special type of binomial that result from multiplying conjugate binomials. I will not spend too much time on talking about what conjugate binomials are, so I'm assuming that you already know it. But today I will talk about what basically show you geometrical approach to see what the difference of squares are or is, and also algebraic identity. So let's start with a square like this, and let's call this side A. Therefore, this is going to be side A because it's a square. So this is going to be A square is the area of this square. So but what happens if we take another smaller area and subtract it from this bigger area? Okay, so such as if we take a smaller area, just a small chunk, and subtract it from there. So let's see what if we actually called sides of this smaller area B, and then area would be B square. Okay, so if we do subtract it in such a way that we get a new area like this, and so this still remains side A. Okay, let me just adapt the thickness, and this also still remains side A. But because I've taken B, like, imagine if there was still there, so this would be B and this would be B, right? And we subtract that B on this side, so this side is now A minus B. Therefore, this side is also going to be A minus B. So we see that now new area is going to be A. Well, let me actually use a different color for that. So it's going to be A square minus B square. So that's a new area now. Okay. However, what if I take this part or this area and take it on front and move it up front and create a new rectangle in such a way? Okay, so now we do still see that this is A, or let me actually better, yeah, this is A, and then this side is B, this small part is B, and therefore the entire length of this rectangle is going to be A plus B. So I'm sorry because my daughter is crying in another room. Hope that you don't mind that. So that's length, but the width is now going to be A minus B. So I'm going to write that here, A minus B. Okay, as you can see. So the total area here is A plus B times A minus B, which is nothing but the length times width. Okay, so you see, so now we see that A square minus B square, as we have up here, is equivalent to A plus B times A minus B. So we get new formula. I'm going to box it in because we're going to use it. Okay, but so we see the geometrical representation, and we also see algebraic identity here, and that's what we're going to use. But before we use that, let's check if this is correct. What if I actually have A plus B times A minus B, and if I use FOIL rule and multiply a times a, that gives me a squared, and then a times negative b gives me negative a b, and then again we multiply b times a, which gives us positive ab, and then b times negative b gives us negative b squared. We see the ab plus negative ab plus ab gives us 0, so that's gone, and what's remaining is a squared minus b squared, which means it checks out, so the equation or identity is correct. So now let's do a couple examples. Okay, so first let me actually write the formula here. So a plus b times a minus b, that's equivalent to a squared minus b squared. Okay, so let's do example 1. So let's start with a simple one, x squared minus 9. So first we have to see if we actually do have a difference of a squares, if both terms are the squares. Okay, difference, it is difference because we see that is minus here, but are they both square? So we see this one is the square, but is this one the square? That's the question. Okay, so let's see, x squared minus, so can I multiply a number by itself, or can I square a number and get 9? Yes, there will be 3 squared. So we do see that we have 2 squares, so we have difference of 2 squares. So now we're just going to open double parentheses, as you can see in the formula up here. So in our case, a is x, so we're going to use x, and b is 3. So you just plug that in. Okay, and then we use either opposite signs, so we can use minus and plus, or plus and minus, doesn't matter which one goes first. Okay, that's it. So let's see another example. Example 2, I'm gonna say, what if we have 4x squared minus 1? So now again, we have to determine first if both of them are squares, but I see that 4x squared I can write as 2x, and I raise that all to square, or second power, minus 1 I can write square because 1 square is still 1. So I have 2 squares, so a difference of 2 squares. So now again, I open parentheses, and I just, instead of, see, in our case, this case, a is going to be 2x, and b is going to be 1, and then we just use plus or minus and plus, doesn't matter, and we are done. So let's have another example. Example 3. What if we have, let's say, 9x squared minus 25. Again, we have to first see if both of those terms are squares. I see the first one I can write as 3x squared, and the second one I can write as a 5 squared. So therefore, opening parentheses. In this case, 3x is a, so I'm going to write down 3x, and I see the b is 5. And then I'm going to use just plus and minus opposite signs. And that's it. Let's do one more example. Example 4. So let's do 2x squared minus 18. So you see the first one is, that would be a little difficult to write it as a square. It's possible, but it's a little difficult. But we see that we have a greatest common factor here, right? Which is 2. So we're going to factor out 2. So we get x squared minus 9. And now we recognize we had x squared minus 9 up here, the first example, but we're just going to do it all over again. So 2 times x squared minus 3 squared. So we see that that gives us 2 times, and I'm going to open 2 parentheses like this. And then in this case, a is x, b is 3, and then we just have opposite signs. Okay, so that's pretty much what we need to know at this point. So we learned we saw how we can represent difference of the squares geometrically and how we develop arithmetic algebraic equation or identity. And hopefully this will help. If you need additional help or any other questions, please write in the comments and let me know, and I will gladly do that for you. Thank you, and have fun.